cousins in binary tree. So in this question, what you have to do is, we have given a binary tree and then we have given two nodes. That is, like for example in this question there is 4 and 3. Here we have to tell if these are cousins or not. So in a binary tree, cousins are those elements which are at the same level but they have different parents. So for example, if I take this one, we have 1, then we have 2 and 3, then 4, 5 and 6, 7. So in this question, if you have this kind of tree, then 2 and 3 are children of same node, so these are not cousins. 4 and 5 are children of same nodes, so they are not cousins. But 5 and 6 and 5 and 7, so 5 and 6, 5 and 7, 4 and 6 and 4 and 7 are cousins. Perfect. So these are the cousins. So basically what do we have to do is, like, we have to check the level that they consist in same level or not. So when we talk about levels, the first thing that comes in my mind is queues. Okay, so now I can understand, like, we have to use data structure queue. Then what do we have to do is, we have to see that in this level they don't contain the same parent. So how do we travel in queues? So first I will push 1 in the queue, and then I will pop this one, and then I will push its children, that is 2 and 3. So 2 and 3. So here we have given two nodes, right? 4 and 3. So I have to check. Okay, so 4 and 3. Okay, so for example, if I'm checking 4 and 6 for this, in this question I'm checking for 4 and 6, okay, if they are cousins or not. Okay, so now we are coming to another level, that is, we will pop children of 2, that is, we will pop these two elements, and then we will insert children of these two elements inside the queue, that is 4 and 5 of 2. Now we have got 4. So what I can do is, and it's of the same parent. So here I can check, like, even while I'm popping 2, if its children are 4 and 6, if its children are 4 and 6, then at that time I can return false key if this node contains two children and that are 4 and 6, which is question is asking, the elements that question is asking, then we can return false because they are children of the same parent, they can't be cousins. And if not, then I want that at this level if I am getting these two elements or not. That's it. 4 and 5, and this level I will also push 6 and 7, which are the elements of 3. So these would be my 3 levels of queues. So I have to do two things. One thing that I have to do is, like, I have to check ki in one level am I getting these two elements or not. The elements which the question is asking, I'm getting these two elements or not. That is first thing that I need to check. Second thing I have to check, these two elements, if I'm getting it, that's okay, but these two elements shouldn't be part of the same parent, or they shouldn't have the same parent. So these are the two things. Now let's get to the coding part and it would be more clear to you guys. So here what am I doing is, I want a queue, and this queue would be of, like, I will make it of root only, or tree node. I will be pushing nodes inside this queue. I'm naming it queue only. I will push the first node inside this queue, queue.push root, while now I will start my loop while queue dot empty, while queue is not empty. Okay, so while queue is not empty, what you have to do is, while queue is not empty, first I want the int size, queue dot size, then I will keep popping these elements while size minus minus, not size minus minus, while size, okay. Now while size we have int, yeah, we'll make it 3 node start temp equals to q dot front, q dot pop. I'm popping the first element of the queue. Then if temp left equals to x and temp right equals to y, or all, I'll put this in bracket, here temp left equals to y and temp right equals to x. So here I'm just checking like whatever element I have popped, if its child elements are equal to x or y, so either the left can be equal to x and right can be equal to y, or y can be equal to left and right can be equal to x. So if that's the case, then at that point I have to return false, so there's no point of calculating further. If not, then what I want is I will write bool left, and which is equal to false, and I want a bool right equals to false. It's the left element. Yeah, I can write num1 and num2 here. Bool num1 num2. So whenever I get this num1 and num2, I will make them true. So in the starting of the level, num1 equals to false and num2 equals to false. At the starting of the level, I have to make num1 and num2 false. So rather than declare, I'm just declaring it over here. I will give the value it in the loop only. I have just declared it num1 and num2. So in the starting of the level, both these num1 and num2 are false. Now if temp now q dot push, if root or temp left exists, if it's left exists, I have to q dot push temp left. If it exists, I'm pushing it inside the queue. If temp's left val is equal to x, then I'm making num1 equals to true. If temp left val is equal to y, then I'm making num2 true. This is for the left case. So what I have done is, like, I'm checking if that number contains its left element or not. If it contains, then I'm pushing that left element inside the queue. I'm checking if this element is equal to x, one of the numbers that the question is asking to check if they are cousins or not. If it is, then I'm making num1 true. If it is the second element, then I'm making num2 true. And I will copy this and I have to do it similarly for the right element. So here I will be just substituting left with right, right over here also, right over here also. And after this is done, this is for the while size, and here it would be size minus minus, because after we are popping one element, we are decreasing its size only. And after this is done, when we come to the level 1, this while loop is telling me about each level. So if num1 equals to true and num2 equals to true, I will return true. Else if num1 equals to true, okay, I have to cousins are basically, they should have same level, right? Two nodes are, if they have the same depth but different parents. Okay, so if num1 is true or num2 is true. So if we get any one of the elements, then, and not both the elements, only one of the elements, then we have to return false. And if not, then in the last we definitely have to return false. Let's see if this works or not. Okay, temp left. Okay, so here we are using temp left, and it should be, we are comparing the node with the value. So instead of this, it should be val over here, and here also it should be val. For right also it should be val, and here also it should be val. Let's run this. Perfect, it got accepted. Let's submit this as well. Runtime error. So why are we getting a runtime error? So the question is something like this. Let's give it a dry run. So this is my test case. So it's something like 1 2 3, then null, then I have null and 4, and null and 5. So I pushed 1. So what am I comparing over here? 4 5 and 4, 5 and 4. Okay, so I'm checking if 5 and 4 are cousins or not. So I have 1, I pushed 1, then I popped 1. So I pushed 1 in my queue, then I popped 1, and I pushed 2 and 3. Then I popped 2 and 3. I saw that if there's a left element, if it exists, it doesn't, then I check the right element, then if it is there, I pushed it. And for 3 also I pushed it. Then why is it giving me the runtime error? Just a second. Okay, let me check if temp of right exists, temp of the, actually I'm getting the error over here. Okay, so here I have to also make another check, temp of left exists, and here I have to make another check for temp of left exists here, and this, and for this also temp of right. So I can write it in a better way. If temp of left and temp of, oh just a second, where did it go? This was my right, this was the case, right? I will write if, yeah, if temp of left exists and temp of right exists, then only I have to check this, otherwise there is no point of checking this. Yeah, let's submit it once again. Perfect, guys, it's faster than 77%. Basically the error what we were getting was, like, we were comparing the left node if it is equal to x or y, and right node x or y, but at the same time we also have to check that if it there's some left node of that current node. For example, like there's a left child node of that node. If it exists, then we have to check if it is equal to x or y. So that's what we did, and it's faster than 77%. Perfect. So this is how you solve cousins in binary tree. And if you like this video, do subscribe to my channel and hit that like button. Bye bye.